Well, good evening out there to everyone. You're listening to and watching Amateur Radio Roundtable. This is a show about shortwave, about ham radio, and we're glad you're with us tonight. Let me first say hello to all our guests listening out there on international shortwave on world-famous station WBCQ up in Monticello, Maine, on 7490 kilohertz. We welcome you. We're glad you're out there listening on shortwave. Many of us got our start many years ago just listening to shortwave, and that's how we got into ham radio. So we're so glad to have you. If you will, send us an email and let us know where you are in the world and tell us how you're hearing the station. You can send that email to Tom at w5kub.com, and we'll be glad to hear from you, and we'll answer your email and say hi back to you there. And hey, if you want to, you can join our show live on Tuesday nights at 8 p.m. Central Time. That would be now 0200 UTC on Wednesdays. If you just go to w5kub.com, you can watch the show, you can get in the chat room, you can chat with us. So again, welcome to all of our listeners out there. Let me just mention our podcast. We're carried on nearly every podcast carrier out there, from iTunes to Google Play to iNet Radio. What? I got an error. Okay. Anyway, hey, join our Facebook group if you will. We've got a great Facebook group that follows the show, and the thing here is just all about ham radio. And that Facebook group is called W5KUB. It's actually called Amateur Radio Roundtable, but that's way too much to type in. So you'll just type in W5KUB. You can find it. We'd love to have you join. We got about 13,000 members now. YouTube changed the thing around, and we don't really know how many members we got now. I mean, I see 20 people every day joining. It's saying we're just about 100 below 13,000, I think. I see 20 people a day joining, but the number never goes up on the count here. So I don't know what's going on, but hey, please join us. If you will, subscribe to our channel, our YouTube channel there. It is called, well, you know what it's called. You're on it right there. In fact, I'm helping you out. You'll just click that subscribe button. It's down here somewhere. That will really help us out to promote the show. So we really appreciate it if you do that for us. All right, let's see. Oh man. Hey, first things first, guys. I'm going to be weatherman. Look at this. Look at this. You believe this? You believe this? Let's see, where's Memphis? Memphis is right about, I don't know. Help me, Glenn. Where's Memphis?
Down, right there.
Memphis, here we are. We're right about right here, and you guys can see what's going on here right now. It's a storm kind of moving this way, so I don't know, you know. The lights may flicker a little bit, but hey, guess what? We are on a big generator. It will come on automatically, and it should keep the show going. So, you know, the entire house, everything runs on the generator, but of course we could lose the internet if they lose power down the road somewhere. You know, I'm not going to supply them power, you know, a half a mile down the road. I do help my neighbor out next door when we have a power outage. He brings an extension cord over and plugs it into the house here, and that gets all of his essentials running there.
You won't even bring that extension cord over to my house when my power goes out.
Yeah, well, it'd take a long extension cord, and you know, if you know anything about electronics, there's going to be a heavy voltage drop between here and there.
Oh, probably. Well, then you got to cross the state line too. So
although since it is AC, we can use some step down transformers on the way. See,
right?
I could jack that thing up to about 8,000, maybe 12,000 volts. I could probably get it down close to you.
Yeah, probably. But then you got to cross the state line, and you've got to make the phase go back 10 years.
Well, that's true. That's true. So anyway, you work for the power company down here anyway, so
yeah, I control your power.
I don't know what you're worried about. You work for the power company.
All you need, Tom, is a gigantic Tesla tower. And
Tesla tower, and just send that voltage down to him, right? Well, hey, I've got a 40-meter extended double ZEP up here. I guess I could.
Pump Tesla could light bulbs 20 miles away.
Yeah. So, hey, Bill, are you aware of this right here? Let's see. Are you?
Oh yeah.
Are you aware?
Yeah, we're waiting for it.
You're waiting for it to get down there. You're probably a couple hours behind us, maybe. It's just supposed to get here at 8 o'clock tonight.
Supposed to hit here about 3 in the morning and rain about 5 inches and create a lake where because we've had rain for the last 2 weeks, so it has nowhere to go.
Well, I was going to get some. I've got so many people know I have so many big trees. Even though a number of my big 100-foot trees have fallen on the house over the last couple of years, I still have a lot of big trees. And I tell you, boy, I have leaves, but I've got one of those cyclone rakes, that you pull behind your tractor, and it just sucks them all up, man. It'll suck the dirt up if the ground's dry. And I thought I had just about all my leaves up. Boy, it's looking good. Just in the back, there were some big trees that hadn't fallen yet. And we went to New Orleans. I was in New Orleans Thursday and Friday for a college graduation down there. And man, when I came back, I looked at that backyard. I have never seen so many leaves on the ground in all my life, man. It looks like a sea back here. And so I'm kind of waiting for them to dry out. It looks like it's going to rain tonight. So,
if you get some high winds in that, it'll probably blow the leaves over here.
Yeah, it might. So
I just go out in the backyard with a blowtorch and burn them in place, and the ones on the trees refuse to fall after that.
Well, man, I'll tell you, the only other thing I hate about it is I got some gumball trees back here. I hate gumballs.
Oh, man, those things are a mess.
I hate them, man.
And I call them the coronavirus trees.
Yeah.
Because the sweet gumballs look just like coronavirus.
You get those gumballs.
They do as much damage as you step on them.
Yeah, and I get all those gumballs up, and I think, okay, hey, man, we're looking really good, And boy, next morning I look, and there's double the gumballs out there on the ground. I don't know where they're coming from. I think my neighbors maybe throwing some over.
If I can find it in the garage, I have the ultimate tool for that. And it's a sweet gumball collector. It looks like a bingo cage. Yeah. And you just roll that over them and it'll collect them.
Yeah. Well,
I think I got it at Lowe's, but it's really phenomenal. It makes all the difference.
Man. Well, anyway, hey, Bill, welcome here with us tonight. We got you, we got Glenn with us. Alan, man, since COVID kind of cleared up, Alan's been out working. He travels a lot. We are going to have a video from Alan tonight. We're going to talk about some scope probes. And I've used scopes a lot on and off, during my many years, in electronics, and it was still very interesting. I've looked at this, and it's very interesting to see how these probes are built, where you can compensate them for the low frequencies and high frequencies and so forth. And you might actually learn something. It's pretty neat, man. And I've got a bunch of scope leads here, Bill. I got a bunch of ones, and I got a bunch of tens. I got a bunch of ones and tens, and I guess you got one of these with your scope, didn't you? This is 100. This is a times 100. You bought one of those scopes, didn't you? Where'd Bill go?
Yes, I certainly did.
Yeah. Ooh.
You need to get a commission for everything you show on the show that I buy.
That's true. That's true. I need to. I don't know. Something looks a little funny with this. And this end here looks like it's going to come loose. That's just a press relief, I guess. Anyway, I haven't played with it yet, but it's 100. It's 100 to 1 scope probe. So this is going to be interesting playing with this.
Yes, that's for the higher voltage scenarios.
Well, hey, higher voltage, but I didn't really realize this until I looked at some of Alan's videos. The bandwidth on these on the time one probe is not very much. You may have a 100 meg bandwidth scope, but a time one probe may only give you 2 or 3 megs of bandwidth.
We had FET probes that cost $500 or $600 for the probe that worked, but the nice thing about it is it was such high impedance that it didn't load down the circuit at all.
Yeah. Well, that's what the times 10
But they're
does.
expensive.
Yeah. I've looked at some there. So we're going to be talking about that in a little while. I think it's a neat video, and he's very good about talking about how to compensate the probes and why you want to and which ones to use and so forth. You know, I was going to talk a little about homebrew tonight on a couple of things, and man, I had a project I was going to show you guys tonight. It was a homebrew microphone built out of a shower head. It looked cool, man. Let me see how many people in the chat room have a microphone built out of a shower head. Probably nobody. So if you want to be different from all the other hams out there, I'll try to find it. Now, I did pull up one thing on the internet when I was looking for it tonight, but it's the opposite. It's a shower head that is built like a microphone. So let me see if I can find it. Let me see if I can find it here. Let's see. There he is right there. Hey, this might make a good Christmas present for somebody right there. It's a deco style a shower head, but it's made like a microphone. Okay, so guys, you can get that for $10.85 right there. So you know you might want to get that for you, or maybe if your spouse is watching, maybe that might be a present they can get you. Anyway, so I didn't find the microphone built out of a shower head, but you know that's pretty neat. And we try to make one for the show. We try to make different things here, but let's see, Glenn.
Yes, sir.
What are you doing down there? I know you're working on the books. Are you making any progress?
Yes. Everything is done on it. All of the projects have been built, coded, documented, the whole 9 yards. Everything's organized. And I've got the table of contents put together, and all of the front part of the book is done. And I'm still on track to finish it right around Christmas time. But it's taking up every minute I got.
All right. So now when you finish that, are you going to have some free time after that?
Define free time.
Well, time to play with your 9700 and take it out of the box. And, kind of thing.
Probably just enough, because I have to turn around and I've got another book that's due for another publisher, and that one's due in September. So I have a little bit of playing around time into the schedule, but got another one coming right up.
Well, you're no fun anymore. All work, man. I don't know.
Oh, what, you call building all these fun things work?
Well, I don't know, man.
I mean, I think one of my favorite projects that I built here recently has been that RIDI decoder. I can just hook it up to the radio and it'll read the RIDI for me without that big clunking motor and relays and all of that.
Why don't you, hey, just a suggestion, if you have a little extra space in your book you need to fill, why don't you put in there a shower microphone?
But it's not going to be Arduino powered.
Well, I don't know.
We'll have to come up with another book for that one.
Yeah, okay.
But,
yeah. Well, look, hey, guys, let us know. I'd like to do a show next week maybe and talk about weird ham radio things. If it's weird, I want to see a picture of it, and things like shower head microphones and stuff like that.
Well, what I want is one of those chips that can give you that same smell of the Model 15 teletype while it's printing. That really nice oil smell that it would do.
Yeah, I can still smell that today, man. I think the oil's still in my skin.
Yeah.
I was thinking about teletype today. I don't know. You know, technology has moved along so rapidly. I mean, back when we were playing with the Model 28s, Model 19s, and 14s, did we ever imagine that you'd have a flat panel monitor up there copying RTTY? Probably not.
No, you know, completely software driven for sending and receiving. No.
Yeah, it was all mechanical back then.
I mean, I remember winding them 88 millihenry toroids forever for the terminal units.
You know, I've thought about that this week. You take that little round 88 millihenry toroid and get your capacitor there and your scope and your audio generator, and you just start taking turns off until you get that sucker right where you want it, and that was a lot of fun. And,
yeah, it really was.
Hadn't done any of that in a long time, and now, oh man, now I've got this spectrum analyzer with tracking generator and all that. I just hook it on there, man, and it shows the dip and everything. And
exactly,
it's so cool, man.
Yeah, it's kind of taking the fun out of it, though.
Yeah. So speaking of the spectrum generator, let me show you real quick which one I got there. And I think Bill orders everything I order. I don't know. Bill, I ordered Tesla, the high dollar Tesla yesterday. If you want to go ahead and place your order, go ahead. But so
an actual card.
Yeah. So here's the scope. This is an automatic scope. I mean, you don't have to fool with turning all the knobs like you do on the old analog scopes. And you just hit a button that says auto on it, and it'll tune the knobs basically for you, man. It just comes right in. So anyway, I bought one of these, and I played with it a little bit, but I still like the old stuff, kind of the old things. And look, so I went out just a week later, and I ordered me a Tektronix.
There you go.
Right there. So, that's not a large Tektronix. That's a 2235, I think, dual channel, 100 meg. And I've been comparing it with the new modern scope, and they're pretty close, actually. I wasn't too sure how accurate that cheap autoscope was, but it's pretty close, I think. So anyway, I got that in. That's going to be my Christmas present, I guess. I buy this kind of stuff all the time, so I have Christmas all the time. So
I used to have one just like that one. That's a beautiful scope.
Yeah, this may be yours.
Actually, I've got an older 465 scope in my closet that I love to use.
Yeah.
And, it gets nice and warm, and you can just smell the warmth coming out of that thing, and it's just so fun to use.
I still have a 465, and it still powers right up.
That's very popular scope, the 465. Here's the spectrum analyzer that I bought and Bill ordered. And by the way, Bill, I ordered that Tesla yesterday, so you better get it in order. This is the Regal DSA 815 spectrum analyzer with tracking generator in it. And it is so cool, man. You turn that tracking generator on, and you can put this thing across a filter or a coil or an LC circuit, and you can just watch that dip in it right there. I've been playing with it to make some to filter out some like third harmonics on our trackers. And in fact, I may have a picture here. Maybe here's pictures. I was kind of playing with it. Above there, you can see the second third harmonic are quite high there, and you can see in the next picture down they're quite attenuated. And that was just with a little hand wound coil on a drinking straw, a capacitor. And that was actually, I think the configuration here, that was actually, that circuit right there. And, I've really enjoyed playing with that. So even though that spectrum analyzer was a little expensive, I'm really learning a lot and playing a lot with it and enjoy it. Okay, all right, so we're going to jump into a video in a minute that Alan made. Well, first, let's see if Bill has any hot pending news. Bill, anything going on there that you're just itching to tell us about?
Oh yeah, just getting ready for Christmas. Just wondered what you have for your Christmas wish. I mean, you won that big radio at the Huntsville Ham Fest. So what can we get you for Christmas? And how about you, Glenn? What do you got on your Christmas list?
Ooh, I'll let Tom go first.
Well, okay. In fact, this is the first year Kathy and I have decided not to get a present for each other. We're not doing it this year because every month I do something like this or this or this, or I win maybe the 9700. There's for the grandkids, I try to, they always want to buy you something. So I'll go down to Harbor Freight and take my pencil and paper and I'll write get me package of this, or get me this package of screwdrivers, or this some cheap stuff, and put that on my list, and that's what the kids would get me. But we've decided not to get anything. But I would like to know, hey, when we come up near Christmas, probably be right after Christmas, I'd like to hear from people out there, and we got too many people that are mic shy. I don't believe they should be mic shy for ham radio operators. I want to hear from you what you got for Christmas, and we'll even show some pictures. And like the old talk about your shack pictures. Let's see you with your new Christmas presents, and we'll do that after Christmas. So, Glenn, what are you going to have?
Well, actually, I've been holding Christmas all year long. About once a month, I would buy me a new toy. I bought the FT101 Max, the MP. I bought the 9700. I bought the 3D printer and the CNC and laser cutter. And believe it or not, most of those are still in the boxes. So I think for Christmas, I'm just going to start opening boxes and put stuff where it needs to go and play with it for the whole day.
Well, that's good. That's what
I really can't. Yeah, I'm doing the 12 months of Christmas. I really can't think of anything I really need for Christmas at this point. I bought it already.
All
right. Well, hey, I think we're going to have a good Christmas.
A great Christmas present a while back. I actually got a Weller WX2 soldering iron.
Oh, wow.
The thing cost about $800, but I use that just about every day. It is a wonderful, wonderful beast. And, people think, well, a soldering iron is just a soldering iron. Well, no. If you're working on this surface mount, tiny stuff, you got to have an iron kind of like that with a very, very fine tip. And this one's great because I can change, just like a golfer changes his golf clubs for different things.
Yeah.
This one's a fast disconnect. It actually uses an audio plug on it for the power, and you just pull it off, put another one on, and it's all cool to the touch when you do it. So I can instantly change the tips to anything I want, and it is just wonderful, wonderful. I can't speak more highly of that particular soldering iron.
I can change my tips, but they're hot. They gave me a little thing to wrap around a tip to pull off. But anyway, I don't have near the soldering station that you've got there. That sounds really, really great. But I see on some of these ham radio groups where people are getting in a hobby and saying, "Boy, I need to get me a good soldering station. What's a good one?" And I've seen all these suggestions. Hey, Kong He Fat Chevy model. You can get for $39.95, and man, it's outstanding. But I don't think those guys really know well, how do I say this? It might work for them soldering a couple pieces of wire together, like you're saying, Bill. The surface mount stuff is really a lot different. And hey, Bill, hey,
just
go ahead.
Just a quick story on soldering irons. I used to sell kits, and then one kit came back, and the guy said, "Your kit doesn't work. Can you fix it?" I said, "Okay, send it back." There were holes completely through the circuit board.
Holy cow.
And I asked him, "What kind of soldering iron are you using?" He said, "Soldering iron? I'm using a soldering gun."
Yeah.
It was a 250 watt Weller solder gun he was using to try and solder the stuff.
Yeah,
Good
well,
for
Bill, you know,
antennas.
most of my electronics life, I used the soldering gun, a Weller, you know, the dual heat Weller gun. You know, growing up with my uncle in a TV shop and things like that, I mean, that's what we used. I built, well, back then, you know, you take a 1 watt or half watt resistor, soldering gun's fine for that kind of stuff, you know. These chips and stuff didn't start coming out till later in life, you know. And
It actually burnt holes completely through the circuit board.
yeah. Well, Bill, you know, I when I was years ago, we built a microwave TV receiver. It was Golden West. It was a station that Gene Autry put on in Memphis. It was before cable came here, and it was a 1-channel movie channel subscription, and they had an antenna on top of the big the tall building here in Memphis, and it was real simple to decode it with a coffee can and a little homemade dish and you know, a little variable voltage tuned oscillator, you know, to tune the picture in. And you know, it used some small things in it. I'm not sure now. I don't remember what parts were in it. It wasn't very many parts, but they were small. And I had this kid, this ham friend, lived down the street, and he's kind of wild, but he had one of these soldering irons like you would solder gutters with. You know, it had the wooden handle on it, and the big part around the metal there, and the tip about the size of your thumb. And
that's what they use for stained glass windows.
Yeah, yeah. So we're starting at that point to get into microwave stuff. I mean, you know, I don't remember what it was. It was like 1 or 2 gig, but you know. Anyway, he used that soldering iron, and he could build those little receivers, and it'd work. And we were having trouble making them work. So I don't know, man. I think if you know what you're doing, and you got the wrong soldering iron, you can still be successful there. But
Oh yeah,
you need a lot of heat in one spot. That's the one iron to get.
that's true. Well, you know, there's a couple stories here. For years, I've used the traditional soldering pencil without even variable temperature.
yeah.
And that's what I used. And then probably about 10, 15 years ago, I decided to invest in one of those cheap soldering stations with the hot air and everything. And let me tell you what, you can call them cheap, but for somebody coming up from where I came from, they're sweet. They're nice. They get the job done, you know, and yeah, I'd love to have an $800 soldering station, but you know, until I can get Bill to buy me one for Christmas, I'm just going to keep going with what I got.
Well, I had one guy send a kit back to me that didn't work. He said, "I soldered it and it doesn't work." And when I got it back, what he had done is put the components in and put soldered paste on it.
Oh,
and figured that's all he had to do.
Oh,
well,
wow.
he may have used, well, I don't know. If he's used a gun, hopefully he didn't use acid core solder.
Yeah.
Well, he put the paste on it, but he didn't heat it.
Oh, yeah, yeah.
Well, you know, there's one thing about the guns, and that's my other story. I was almost this many years old when I realized that on the soldering gun, of course, there are 2 stops.
Yep, yep.
And for years, I thought that when you squeeze that trigger tight, that was max wattage. No, it's the first step that's max wattage. The second step drops it to like 125 watts or something like that. And for years, I couldn't get the heat until I realized, like, oh, back off a little bit, and boom. You know, now I got the full 250.
Same thing. The exact same thing, Glenn.
And I read about that. I read about that. We're going to test that on a show one night, you know. I mean, hey, it would be easy. It'd be easy going in and just switch the wires on that finger switch, you know, and change it. But yeah, you know, so this is the smaller. This is a two heat. You know, man, it's so old now. But I forget what it was. It's like 140 and maybe what, 180 or something. I don't know. You can hear the clicking. You can hear it. There's 2 positions on it for sure. And I always thought that the second position was the hottest too, but you're telling me what I read, that first position is the hottest, and the second position is cooler. Anyway, I've got the Weller 250 watt one out in my shop. It's just like this, but it's a little bit larger. And you know what? I'm gonna plug it into a watt meter or something, and we'll just prove on a show one night that that the second position is low heat.
Yeah, that's how I proved mine. Is I have this wall AC watt meter, and plugged it in, and sure enough, the first position pulled a lot more current than the second position.
Hey Tom, WA7JOS mentioned he had a Metcal at work.
Yeah.
How did your Metcal work out for you? You bought one, didn't you?
Yeah, I got my Metcal right here. It seems to be pretty good. But I tell you, here's the here's the iron itself, and it gets hot. If you need to change the tips, it comes with a little thing here. Maybe he has the same thing. You wrap that around it, and you just slide the tip off like that, and you take your other tip and just slide it on like that, and you're ready to go. Now, Bill, I have found on some of my little circuit boards, that little fine tip there, I don't think it gets hot enough to really, some of the heavy ground traces is where I have a problem with this little small tip.
Well, that's where you use the soldering gun on the first knot.
Yeah, so I typically use the medium size. I typically kind of use this medium size tip. I don't know how many different tips are out there. I've got 3 different tips for it that I use that's getting me by. I'm sure they have many different kind of tips. Probably, chisel tips and flat tips and scraper tips and bent tips. So maybe if he has one in the chat room, he can tell me if there's any special tip that he likes to use. I might need to order some.
Well, that is one thing I like about the Heiko style compatible soldering pencils is they've got a huge array of tips that you can order.
Yeah.
I actually like the Heiko or Heiko.
H-double-A-K-O, however you want to pronounce it.
I love those little irons. We actually had one at work that we used for a lot of stuff. Heiko makes a really good, does make a really good iron, actually.
Yeah, that's what I've been using, and I really like them, and I generally have a spare iron and cable or 2 because my first one, I actually wore it out and it stopped working. And I was like, oh, dear God, fortunately I had a spare, or I would have had to completely shut down and wait for a new one to come in from China.
Well, they make a solder station that's digitally controlled too, so
that's what I'm using.
Oh, good. Yeah.
Yeah, I've got the digitally controlled solder station, which has got the hot air and the soldering pencil, and they're both separately temperature controlled. And the hot air has a what do you want to call it? A speed control on the fan.
Yeah. Hey, I just saw this on my workbench. I tore it out of I'm throwing away all my old CQ and QRZ QST magazines. I've got like 8,000 of them. But I tear interesting things that I was just going to mention. I got my license in the early 60s. I want you to look at this. I don't know if you can see this. These are the sunspots, and man, it was some good times back then. There is right there is when I got my license. Right there. Look at the sun.
I was just on the other end of that curve.
Look at the.
And it was phenomenal.
Yeah, I tell you, the bands were great back then, man.
I was on the bottom end of that curve in 73, 74.
Yeah. Man, that was the highest number of sunspots it looks like in history then.
Yeah, actually, I was out in California visiting my great uncle on vacation with my parents back in like 68, and he was into CB. and he had one in his car, and with his little 5-watt CB, we worked across the country.
Uh-huh.
So,
We
yeah.
used to work 6-meter FM all over the country.
Yeah.
Just like it was 2 meters. It was just incredible.
Well,
and 10 meters was about as hot as you could imagine.
back then I was on 6-meter AM back then, and boy, it sounded good, and it was just common. It was common every day. Just talk to people up in New York and around, places like that. It was kind of cool.
I got on 6 meters probably about 10 years ago and just absolutely had a blast with it. And I really want to get that station back together.
Have you ever worked skip on 2 meters?
Oh, yes.
It's high enough for 2 meters. It just comes in. It sounds like 20-meter band, and you're talking to people 1,000-mile away or more, and then it just goes whoosh.
Yeah.
And you can tell when it's coming back because it swishes up and down.
Mm-hmm.
You can hear that swishing noise. When the static increases, it's open again.
Yeah. And in Florida, we also had a lot of temperature inversions. So we had a lot of ducting. And I remember working from Miami to West Palm, which is about 75 miles. Whenever I was driving back and forth doing that with 10 watts in the car.
Well, from here,
every summer there's a duct from California to Hawaii. And I've actually worked 2 meters from my car to somebody in Hawaii.
Oh, wow.
2,500 miles on 2-meter FM.
During that time, here I am over in Arkansas, not too far from Memphis. Channel 2, Cuba on Channel 2 would come in on the TV. That was cool, man.
Yeah, that was our thing, was we'd watch Channel 2, and when it started getting a lot of interference, we knew the band was opening up.
Yep, yeah, that's true. Yeah.
Or there's a tornado bearing down on you because it would also produce RF near 55 megahertz or so, and you could see the Channel 2 just turn white.
Yeah.
Then it's time to duck and cover.
Matter of fact, there's a company that is selling a tornado detector, and it does listen on the 6-meter band. Kind of like the lightning detector listening on the 500 kilohertz band.
Yeah.
I think tornadoes are attracted to mobile homes because it's probably the length of the standard single wide is a resonant frequency.
There you go. Well, that and the target that you paint on the roof.
Yeah.
Yeah.
Or your neighbor's roof.
Mark says Channel 2 in Cuba's probably still there.
Yeah, and still in analog. That's probably a very true statement.
Still, I would imagine they're still driving their 57 Chevy down to work here.
Yeah, when I was in college in Santa Barbara, I actually saw Channel 1 TV coming in from New Zealand on 49 megahertz.
Oh, wow.
And you could actually, I had a receiver that could handle PAL and CCAM and NTSC, and I was watching this TV station all the way from New Zealand. It was just pretty awesome.
Yeah, and now Chris is saying that new cars are being shipped without an AM radio.
Oh, let me talk. I've got that on my list to talk about tonight. The car manufacturers are talking about discontinuing AM radios in their cars. Got that on my list. Number one to talk about. So, the FCC they're wanting the car manufacturers to continue with the AM radio. When FM came out, I kind of quit listening to AM. I like the static-free, better sounding music and stuff. But I think there are probably a lot of areas in the country that maybe they can't even pick up an FM station, and they depend on AM. So,
most of the talk radios are there on AM as well.
And I did not know this until I bought a car later. I don't know. I didn't know that there were AM stereo radio stations. I never really thought about it. I knew on FM it was all stereo basically, but I bought a car and the radio had an AM stereo in it. And I tuned down to one of those channels on AM one night and I saw the stereo light come on and I could hear it in the speakers. I'm thinking, my goodness. AM stereo station. I don't know how big those went over or how many there were, but there were some of them out there.
Yeah, there's a few, but there was competing technologies, as I recall. And by the time they settled on one, everybody had moved off to FM.
Yep. All right. Let's see. Let's do this real quick. Let's take a break, and then we'll come back, and we're going to jump into some more stuff here real quick. So we'll be right back with everybody. Don't go away. Happy holidays from Icom. Spice up your ham shack this season with one of Icom's popular handhelds, mobiles, or base stations. These radios are perfect for working your favorite bands while staying inside or venturing outside this winter. It's the most wonderful time of the year to give the gift of Icom. The IC705 is a perfect sidekick and QRP companion. Base station features and functionality that chip your fingers in a portable package. Covering HF 6 meters, 2 meters and 70 centimeters, this compact rig weighs in at just over 2 pounds. With RF direct sampling for most of the HF bands and IF sampling for frequencies above 25 megahertz. The perfect accessory for the IC705 is the optional backpack, the LC192, a special compartment for your IC706 and room for all the accessories. The ID52A is a VHF-UHF dual bander with D-Star and FM dual mode function, and it's the first handheld amateur radio with a full-color 2.3-inch waterfall display. This radio supports conventional FM communications and D-Star simplex, repeater, regional, and worldwide calls over the D-Star Internet Gateway. You can send photos over D-Star with a connected Android device. The ID52A is a perfect companion to the IC705. Both use compatible batteries and headsets, and you can also use the same Android app for D-Star operation. Create your own band openings with the IC9700. This transceiver radio brings direct sampling to the UHF-VHF weak signal world. This all-mode transceiver is loaded with innovative features that are sure to keep you busy. They include faster processors, higher input gain, higher display resolution, and cleaner signal. The IC7300 is a high-performance HF transceiver with a compact design that will far exceed expectations. The transceiver digitizes RF before various receiver stages, reducing inherent noise in different IF stages. The IC7300 changed the way entry-level HF is designed. Happy holidays from Icom America. For more information, visit www.icomamerica.com/amateur. All right. I just wonder, Bill and Glenn and I were all yelling at each other here during that video. Did anybody hear us talking? I'm just wondering if we overpowered. We're on a separate audio channel. No, there's no way you could have heard me. The way the encoder's set up, because the mic wasn't even connected. So I won't ask that question. Okay, hey. Wow, we've talked about shortwave tonight. Man, hey, that brings back the olden days, man. I used to like to listen to Radio Moscow and Havana, Cuba. What is it, Lima, Peru? HCJB, I think. Was that in Lima? If I can remember that right.
Yeah, we were always getting the Cuban radio stations in Miami.
Yeah. You know, shortwave listening got me in trouble in the Air Force. So I had a top secret crypto security clearance, and man, one time they pulled my clearance, and they said, "You've been talking to or listening to Moscow and Havana?" No. Well, I mean, listen to them. So they ran another security check. Talked to all my neighbors. Oh yeah, he's got a piece of wire up out there. He listens to them. So anyway, so they gave me my clearance back after about 2 weeks. But it can get you in trouble, guys. Be careful there.
Yeah, I used to listen to HCJB. I've got a card from them, and they used to play a catchy little tune over and over while you were waiting for the next broadcast from them.
Yeah.
They had a lot of dead airtime on shortwave stations, so they always had this catchy tune. And there was a South African station that had a really cool sound to it.
Yeah. Hey, Hey,
I've recorded some of those.
hey guys, here's our job board right here. I got a job for you. WWVH in Hawaii needs an engineer. They're looking for an engineer. So if you'd like to live in Hawaii, this is not a work from home job, but if you'd like to live in Hawaii, you can apply to WWVH, and you can move down to Hawaii, and hopefully you'll be far enough away from that volcano that the lava won't get you down there. Oh, hey, back to the AM radios. I think one reason that the car manufacturers are wanting to stop it, they're going with all these electric cars now, and that generates noise, and it causes problems. But the FCC has sent a letter to 20 different car companies wanting to find out what they're going to do. The FCC is really wanting them to continue with the AM radio. All right. Hey, let's look at this quick video, and we're going to look at this. This is Alan. Alan did this. It's on scope probes. And you might learn something. I actually enjoyed watching it myself. So let me get it going here, and we'll talk about it after it's over with. So let me see if I can figure out how to get it on here. And okay. All right, might work. Here we go.
Tour of probes and how to use different types of probes, primarily simple passive probes with your oscilloscope, and why you need to use them. So we got to think about, if we're going to connect up our scope to our circuit, how do we do that? Well, you might just say, well, why don't I just use a simple set of probes like I use with my voltmeter, right? I can kind of put them together in this little adapter here, stick it on the front end of the scope. So let's do that. Let's look at what happens. So you can see the scope trace is kind of all full of noise. It's picking up all the 60 cycle hum from my lab bench here, and all the lights and things like that from the ballast and the fluorescence and all kinds of nasty noise. And that's the problem. If you're trying to look at low-level signals and things like that, connecting up with leads like this is going to present a number of different types of problems. And let's look at why. So helps to start off by looking at what the scope input looks like. That's kind of what the oscilloscope input looks like. It's basically almost most of the scopes will have a 1 megohm input impedance, so basically right behind the front panel connector, it looks like a 1 megohm resistor to ground. And that's typically got in parallel with it anywhere from 10 to 25 or 30 picofarads of capacitance, sometimes a little more, sometimes a little less. Okay, so it's a pretty high impedance, just like your voltmeter is, but it also has a lot more bandwidth than your voltmeter, so it's going to pick up all kinds of things. So if we just connect up the wires like we just did, this is what happened here. So we connected up these wires. They basically look like big antennas, okay? And so even if we connect it up to a circuit, if the circuit's not low impedance, you're still going to be injecting noise into your circuit, and you're also going to be injecting noise into your measurement, okay? So it works, as long as your signals are really low frequency, okay, or you've got some really large signals you're dealing with. Otherwise, you're adding a lot of inductance into the measurement path. You're picking up all kinds of stuff with these wires, and they're acting like antennas. And you might even couple some signals to other parts of your circuit. All things that are not really good. So typically why we don't use wires. So another way around that is, well, let's make these wires shielded. Use a piece of coax. And if we do that, so now we can wind up with this situation here. And this actually solves some problems. Okay? Because now that the signal wire is shielded by ground, we're not going to be picking up a lot of signals, so that's good. We're going to minimize coupling to other parts of the circuit, so that's good. Okay? But what's bad about this? Well, it adds a lot of capacitive loading. The way to think about this is that typical coax, the miniature coax you might use, like RG174 or something like that, may have 25 or 30 picofarads of capacitance per foot. And if you're talking 2 or 3 feet of cable, of coax to connect to your circuit, that coupled with the 10, 20 picofarads of capacitance at the input, you could easily add 100 picofarads of capacitance to your circuit by simply connecting the probe. Now, will your circuit care? Depends on your circuit, right? Sometimes it will. You have to remember that 100 picofarads, that looks like 50 ohms at 30 megahertz. That's a far cry from the original 1 megohm input impedance that we were dealing with to begin with. So, but this is a basic 1x probe design, and they're out there, and you just got to be careful when you can use them and when you can't. Just take care, and understand the ramifications of touching this probe to your circuit and how it will affect it. Think about would I want to solder in 100 or 120 picofarads of capacitance to my circuit at the point I'm trying to measure, okay, and expect the circuit to still work. A lot of circuits, will work just fine. Audio circuits, low frequency things, lower impedance circuits, and generally might be okay. But for a large majority of circuits, the amount of loading from a 1x probe is not going to be good. The capacitive loading could really affect the circuit operation. So how do we isolate the capacitive loading of this type of a probe, a 1x probe, from the circuit? Well, one way to do that is to stick a big resistor in series with that. So we stick a 9 megohm resistor in series with the coax. What that's going to do is now all the capacitance is sitting back here is really kind of isolated away from the circuit we're testing over here by this 9 megohm resistor. So your circuit really doesn't see it. So that's good. Okay. Now the resistor, we chose 9 megohms because it gives us a nice convenient 9 megohm to 1 megohm resistor divider here. So it's a 10x resistor divider. Hence, that's the reason why we call this a 10x probe. It doesn't have 10x worth of gain. It has 10x worth of attenuation. So it'll attenuate the circuit, but or attenuate the signal by a factor of 10. But that's pretty easily compensated for. But it also reduces the capacitive loading, so that's good. Now the problem that you can run into though is that the 9 megohm resistor, okay, and the capacitance of the coax and the scope form an RC low pass filter that looks like this, okay. And what happens is as the frequency goes up of what we're looking at here, the capacitive reactance here starts going down, and all of a sudden this the 10x divide ratio that we had because of this resistor starts getting dominated by the capacitive reactance of that capacitor, and we start rolling the signal off. So it's a low-pass filter. So now as the frequency increases, our 10x attenuation got worse and worse and worse. So it didn't really help us that much, but there's actually, it turns out, a pretty simple fix for this, and this is what's typically done with 10x probes. So if we look over here to the last page here, what we do is add a compensation capacitor in parallel with that 9 megohm resistor. And the idea there now is that for low frequencies, the 10x attenuation is dominated by the 9 megohm and 1 megohm resistor. Okay, so that kind of dominates our 10x attenuation. But now as the frequencies go up, okay, the capacitive reactance of the scope input and the probe cable is going to start dominating the input impedance of the scope. And then what we do is we add a compensation capacitor here, which kind of will now track that. So now at higher frequencies, if we make the ratio of this capacitance to this one 10x, okay, now that capacitive voltage divider is going to dominate the attenuation at high frequencies. So now between low frequencies and high frequencies, we've got still 10x attenuation. Okay. Of course, the input impedance at high frequencies is going down because this looks like this series combination of capacitors. But at the end of the day, the probe is still flat in frequency response generally. Okay, so we can account for that, and this is basically the design of commercial 10x probes. Now they're called 10x probes because they attenuate by a factor of 10. So that's something that's important. You've got to think about that. Is that when you connect this probe up to your scope, you've got to remember that the probe is actually attenuating the signal by a factor of 10. Some scopes and probes help you out with that and actually remind you that that's what it's doing, but most of them don't, especially the lower cost ones. So we connect up look at some typical 10x probes here. Let's go take a look at some of these. I'm going to clear out these other probes, CMM probes out of the way here, and let's look at one. Here's a 10x probe. This is a Tektronix P6105. Okay, it's a 100 megahertz 10x probe, 2 meters long. We'll take a look at, this is the part that would connect up to the scope. This is the part that would connect up to your circuit. There's your ground lead right there. A lot of these have got removable spring clip tips, so you can be probing around with the tip here, or you can connect this up and you get a nice retractable clip, so you can clip this thing into your circuit. Okay, number of different variations on this set of combinations, but this is typical of what you'd find. Now, either on the probe handle itself, like this, or on the compensation box or probe body here, you'll find the compensation adjustment. If we look in this one here, we can actually see there's a little screw, the trimmer cap, to set up the compensation for that probe. Here's another example of one here. This is also a Tektronix. This is a P2220. There's our compensation adjustment right there. Okay, and there's our ground lead and our probe to be able to connect up. And we'll look at a couple of other examples too. But one thing I wanted to point out that's different between these two, if you look carefully at the end of these, I don't know if you can see in the camera or not, but there's a little metal pin sticking out of this one. There's not sticking out of this one here, but there's a little metal pin sticking out of the end of the connector here. And what that is, it's something that Tektronix called the Tech Probe interface. And for scopes that were so equipped, when you connected this probe up to the scope had a little sensing ring. In fact, we can look at that over on this scope over here. There's a little sensing ring right around the BNC connector here. And that BNC connector, that little pin connects to that, that would tell the scope that this is a 10x probe that's being attached, and would adjust the scale appropriately. Okay, most scopes, especially non-Tektronix scope, don't have that little sensing ring around the BNC connectors where you connect the scope up. So when it comes to making sure that, okay, is my scale correct for the 10x probe, you've got to worry about that yourself. So even if the scope channel says 50 millivolts per division like it does here, when I connect up a 10x probe, that is now 500 millivolts per division. Okay, it doesn't tell you that, but you've got to think about that. This probe actually has a switch on it, okay, to go from 1x mode, which is just basically a cable connection or coaxial connection right to the probe tip. That's going to have 100 picofarad capacitance or more, but it doesn't have the attenuation. And there's a 10x mode to do what we've been talking about. So now the trick is, how do we adjust that compensation capacitor, okay, to make sure that we match the input capacitance of the scope? Because some of them are quite different. This scope here, that input capacitance might be hard to see, says 25 picofarads. This scope over here, that one says 1 megohm and 15 picofarads. That's quite a difference. And they certainly, a scope that's matched to this scope here wouldn't necessarily match to the other scope over here on the right. So that's why that compensation capacitor is made adjustable. So how do we adjust that? Basically, we use a little test signal, a calibrator signal, a compensation signal, and it's typically a square wave. The square waves are nice because you can have a fairly low frequency square wave that has very fast rising and falling edges. And what that gives you is a waveform that has a lot of low frequency components and high frequency components. Because basically a square wave is fundamental, frequency of the square wave is energy, but then you've also got energy at all the odd harmonics at 3 times that frequency and 5 times and 7 times, etc. The more high order harmonics that you have, the faster the rising and falling edges. So it's a nice waveform that has both, fast, or I should say high frequency energy and low frequency energy in it at the same time. And the way to adjust these probes is actually quite simple. Let's kind of look at the example over here on this scope. Okay, so in this scope here, I've got, this is a P6131 10x probe connected up to channel 1. And on this scope over here is our calibrator signal. Okay, and if I've got the ground lead already connected, if we connect up the scope to it, the probe to it, we can take a look here at the on the waveform. And this one is pretty well compensated. Now you may notice when you get a 10x probe, they'll always come with, when they're new, a little diddle stick, a little screwdriver. This one actually still says Tektronix on it, but it's just basically it's a little non-metallic screwdriver to adjust the compensation capacitor inside the probe. Like I said, sometimes those compensation adjustments will be on the probe body, and sometimes they'll be right on the the probe box that connects up to the scope. And this is the waveform that we're looking at here is typically what you'd ideally want to see, in that it looks like a perfect square wave. And here's what it looks like if you have it misadjusted. If I can engage the screwdriver in here, there we go. And you can see if I make that capacitor too big, okay, we're going to couple more high frequency energy in, and we're going to get this overshoot on the rising and falling edges of the square wave. And if we adjust it the other way, where that capacitor is too small, now we're low pass filtering that square wave, and we get this kind of rolled off response there. So the idea is to adjust this thing. If we kind of go back and forth, we can adjust that until we get a really nice looking square wave. And what we've done now is made sure that the low frequency response is which is kind of set up by the resistor, is now matched by the high frequency response set up by the capacitive voltage divider of the 9 megohm resistor and the parallel capacitance, and then the cable and input scope capacitance. And now this probe will be good for looking at both high frequencies and low frequencies. But notice again, this probe, if we look at the scope, you might see that the scale on the scope says 100 millivolts a division. If I remove this scope, this probe, see that that drops to 10 millivolts a division. This scope, this probe has got that little metal pin, and this scope is automatically sensing that. There are other scopes that sometimes will actually have a little light that will tell you whether you've got 1x or a 10x attenuation, on some of the Tektronix scopes. But the non-Tektronix scopes typically don't have that sensing ring, or at least most of them don't. So if you put a 10x probe on there, you know you've got to multiply your volts per division setting by a factor of 10 when you're using the 10x probe in order to make a calibrated amplitude reading. That's a quick tutorial on what 10x probes are and how to adjust them. Make sure that they're calibrated for anytime you change a scope, and you can use the same probe on a new scope, readjust that for that new scope, because no two scopes really match in terms of their input impedance, and properly adjusted probe on one scope won't necessarily be properly adjusted for another scope.
Right. Well, hey, I thought that was pretty interesting, to tell you the truth. I got to see.
Yeah, that is pretty cool. I've always wondered how that did.
Yeah, this video is in response to a question that one of my YouTube viewers had.
Well, let's stop him here. Be quiet. There you go. All right, we're back. All right, well, let's do this. Hey, I'm going to put the Zoom link out there. Anybody wants to join us on Zoom. So let me paste it. And if you want to, guys, click on that link. You can join us on Zoom right there. Let me start the phone lines up. I'll even bring the phone lines up tonight in case you don't want to use Zoom and you want to just call in on a telephone. You can just call in on a telephone. I'll post the number there in just a moment on the screen. Go. We'll have that going, and let's see if we can get some precipitation going tonight.
Well, I think it's going, but
There's
it's
Charlie.
outside.
That's Charlie. Yeah. So we need to get that. Let's see. Going. All right, I think the phone is set up now.
There's Charlie.
Yeah, Charlie's in there. Hello, Charlie. How you doing?
Hello. How are you?
We're doing good. Boy, see.
You are the only participant in the conference.
I'm the only person.
There you go.
Tim joined us. All right. I'm gonna turn the music down. I'll have to try to watch the phone system there. All right. Okay. Well, hey guys, I guess we are officially into the after the show. Sometimes I forget to put that up, but we're in the after the show. We got about 30 more minutes we're gonna be around. So if you're out there and you want to call in on a telephone, dial that number right there. Or you can click on the Zoom link that I just posted in the chat room. And again, welcome everybody out there listening on International Shortwave on 7490. You guys, shoot us an email to tom@w5kub.com. We'd love to hear from you. And thanks for being with us. This is Amateur Radio Roundtable, a show about ham radio and shortwave.
Hey, Charlie?
Yes.
I just wanted to let you know I sent you a link in the chat room where you can track the balloons that are flying around Antarctica. And one of Tom and got Glenn's call sign on it, KW5GP. It is went across Australia and New Zealand, and it's heading for Chile, and will probably cross Argentina and possibly Uruguay in the next couple of days. and that's the farthest north one since they launched them 2 weeks ago from a Neumayer station, a German station in Antarctica. Tom sent down 2 payloads, W5KUB-114 and W5KUB-115, and then there's several with the call sign K4UAH-1 through -7. So they're all on 20-meter whisper during daylight hours, wherever they are during daylight, and they're being heard on the other side of the world. So they're only 20 milliwatts, but 10 to 20 milliwatts, but they're being heard all over the place. And but we're having trouble with the 10-meter one because there's not very many stations in the southern hemisphere listening on 10-meter whisper. So we've gotten a few reports in the Canary Islands and in California, but and New Zealand. But we really could use some more 10-meter people listening on 10-meter whisper mode. And you can download the Whisper app. It's for a free download for the Whisper. It's WSJT-X. I'll try and post a link.
Yeah. I have the software, of course.
Oh, good.
For digital modes, when I use digital modes, FT8, I do it with a QRP Labs hardware thing, little 5-watt thing, but that plugs directly as a sound card into the computer. So it's like I don't have to connect the equipment. So, but I'll grab a USB sound card and I'll connect it to the. I have here
So we've got
the Alinco HF rig. I'll connect it to the 10-meter whisper. What frequency is the 10-meter whisper? Well, the software will have the frequency there.
Yeah, the whisper will.
It's 28.124.6.
Oh yeah.
Upper sideband.
Okay.
But it'll show you that on the whisper.
Yeah, automatically. Yes. So no problem.
So we've got 2 other balloons in the air that we haven't really given you an update on tonight. One over Venezuela right now. That's 113. That's actually running 100 milliwatts. We've got a 100 milliwatt PA on that one, and it's running 100 milliwatts. And then the one over here off of Japan, it's actually gone up into the Arctic again, past Alaska. This is about the 3rd time that it has ducked into the darkness. It stays up there for about a week at a time, and then it'll pop out. But it's been flying now for 182 days. So we're doing really, really well on that one. Let's see if I can find, let's see. You go to our website, the 2 in Antarctica have been flying for 27 days. What am I? Oh, wait a minute. Let me shrink that a little bit so you can see it. There we go.
Bill, there's your friend. I follow him on Twitter, Ignacio, Lima Uniform 1 Echo Sierra Yankee.
Uh-huh.
He keeps on posting the status of various balloons.
Oh, okay. Well,
Yeah.
these 2 here that were launched in Antarctica have been up 27 days and 21. And if you come on down on our page, you'll see W5KB 112 and 113, and they are, there you go, 185 days and 68 days.
Right.
So they're doing really well. But the one doing 185 days, he likes to disappear. I got to try to keep him from going up into the Arctic. This will be the 3rd trip up there. I don't know, man. I don't know.
There's no sun up there right now.
Yep, no sun for sure. But you can see, look at the path this guy's taking here. I don't know how well you can see that. Oh, let's see.
Hey, your 115, Tom, went right down almost to the South Pole. It came within about, I don't know, 50 miles of the South
Really?
Pole.
Well, I was watching it. It's really hard for me to figure out exactly how many miles. I thought it was within about 200 miles
bottoms
once.
out on the SONHUB and APRSFI. Anything below 88 degrees south, it stops reporting
Really?
on the map.
Well, I think I saw it at 88 once. Yeah.
And it actually says latitude error.
Oh,
But
really?
it still collects the data, but it doesn't display it on the map because it's off the map for them. The only one that works is the original tracker.habhub.org site that shows the correct when it's below 88 degrees latitude. But you had 115 just a couple of days ago came very close to the South Pole.
Yeah. You know, it's interesting down here. Any direction you go is north, just about. I mean, it's weird, man. It's weird. All right. If you would
Well,
like
that'd be
to,
something interesting to listen for, Charlie, particularly the 10-meter one, because we just don't have many stations in the Southern Hemisphere listening on 10-meter whisper. And when 10 meters is open, it's open to the world.
Okay.
You'll see a lot of stations from the Northern Hemisphere on 10.
Yeah, that's the reason. Well, I posted it on the chat that I've just finished connecting my 10-meter antenna, which is it's just the driver element of a 3-element 3-band antenna, but at least it's something. From nothing to that, it's something. So I've installed the rotator too, which is, I think it's useless in an antenna with no reflector or no radiator. Director, right? But I use it to rotate it only 90 degrees.
hey guys, we had offered a certificate if you copied 112 on Whisper for our 180-day celebration. That week, you got a certificate. Well, it was hiding in the dark during that time. It came out for 1 day. And we have one person, certificate number 1 there, N4MXZ, copied it, so he gets a certificate there with Huey, Dewey, and Louie, and we will get that personally autographed as soon as they come back down.
You expected to issue 100,000 certificates.
Do what?
You expected to issue 100,000 certificates.
Well,
because
I don't
the
know why.
amount of
Is that how many zeros we have? Is that how many zeros we have down there?
Like 4 zeros and a 1.
Yeah. I tell you, on some previous flights, we had a lot of people that got certificates. Believe me, I was spending a lot of time printing them up here. So I don't know. Maybe I need to extend that window again when 112 comes back out of hiding. Maybe I need to open that window up again because I only had a 1 week window that if you copied it in that 1 week, you could get the certificate, and it only came out for 1 day, and then it went back. Yeah. I don't know. All right, what else is going on? Hey guys, if you will, call us on the phone. If you don't like to get on Zoom, dial that phone number, 716-427-1083. Put in the code number, 407051 # and join us on the show. Oh, I think I heard the music quit, so no, music's still playing, so we don't have anybody yet. Nobody. I had to call in last week myself just so we'd have somebody on the phone.
I remember the first couple of times I used to phone in. I sometimes lately I sometimes don't get into the chat because we are having the club meetings on Tuesdays. So I arrive late and then I don't turn on the computer and and don't connect. But
Okay. Hey, Bill, when's Todd coming back? He was supposed to be there, what, 1 month? You know, Bill, if he's on his way back?
I believe he's leaving tomorrow.
Okay.
Oh, wow.
So we got all the balloons launched. There was only one failure. One collected ice and came back down slowly. The one that's heading for Chile, Argentina, and possibly Uruguay is K4UAH-2, and on Whisper, on 20-meter Whisper, it's kilowatt mic for Lima Victor Charlie.
Okay.
So we post them to the APRS maps with a different call sign. So, but there's actually no transmission on APRS. There is one, however, that is flying down there. The very first flight they took off is K4UAH-3, and that is strictly on 2-meter APRS.
Mm-hmm.
So it may eventually get far enough north to be able to be heard either in Australia, New Zealand, or Argentina, Uruguay on the APRS frequencies. So,
what frequency? Which frequency? Because we have different frequencies.
I geofence every country, every region, and when it's over that region, it switches.
That's
Argentina
great.
is 144.93.
Uruguay too.
Yeah.
Uruguay is also 93.
Yes, I yes, it's the same as Argentina.
I included Uruguay with Argentina as far as my geofence.
Yes.
So when it detects that it's over Argentina or Uruguay, it'll flip the frequency. It's frequency agile, so it goes to 144.93. Now, Santiago, Chile is 144.39, which is what we use here in the United States. So there's like 10 different frequencies around the world, and I have to flip it wherever I am in the world with the payload.
Right.
So it's a real pain to program all that. I don't know why everybody just didn't decide, particularly in regions like South America, just stay on one frequency. But every country is different.
Hey, we've got
Australia and New Zealand are different.
We've got someone on the phone. Let's see who's on the phone real quick. Who we have on the phone?
KO4RMP, David.
Was it?
Hello, David.
Was it KL4RNC?
NT, RNC.
INC.
And Romeo November Tango, as far as I know.
Well, what's the prefix? KD?
Kilo, Oscar.
KO. Okay, I got you.
November Tango.
All right. How you doing, David? Man, glad you called in.
Not bad. I appreciate your thing on scope probes. I just got a scope.
What scope did you
get? Excuse me?
What scope did you get?
A Tektronix. But I'd have to go look at the...
Yeah, there's a bunch of them out there, but you know, a Tektronix, to me, a Tektronix is a Tektronix, and you'll enjoy it. You'll have a lot of fun with it.
Well, yeah, I'm going to have to find something to look at, too.
Yeah?
I'm an old new person.
whole new person. Okay, well, that's good. Always something to learn. You know, you can use your scope. You can use it as a voltmeter. You can measure voltage with it. You know, you can look at waveforms, and you can do all kinds of things with it.
Yeah, I use mine to measure frequency.
Yeah.
That's what I plan to do as soon as I find something to look at. It's a Tektronix 2215A.
Okay, well, I tell you, this one right here is a 2235. They make several in that 2200 range. There's a 2215, a 2225. This is what I say this was, a 2235.
Yeah.
This is a 2235, I think. So there's several of them in this category here. Probably looks almost identical to this.
Yep.
60 megahertz.
Okay, well, this is 100, but the scope's probably about the same size and looks. All right. Have you got you some scope probes to use with it?
Well, I got one. I haven't looked at the probe yet. I don't know if it's a 1 or a times 10. But I want to get another probe.
Well, your probe may have a little switch. A lot of them have a little switch on there you can flip from 1 to times 10. It'd be right there on the handle there, you know, where you hold it. Let me show you. I'll stick mine up there and show you the one with the switch on it. So you can see right there. There's a 1 and a times 10. I can't get a good focus on it, but there it is, right there.
Yeah. I see. You got the good probe. Yeah.
Well, I've got some Tektronix probes. I've got a bunch of different probes. In fact, I've got a whole drawer full of them over there. I need to. I was playing with them the other day and calibrating each of them on the scope, and they all calibrate kind of differently. This Tektronix here, actually, it doesn't have the little screw in the bottom like that one does. This one you loosen. See. Yeah. On this one you loosen the handle a little bit, and then you turn it. You turn it inside here, and then you tighten the handle back down on this one. That's how you calibrate that probe right there. I'm anxious to play with this 100, Bill, and see how it acts.
Oh yeah, this has a switch, so it is a times 1 times 10.
Yeah. So you got the switch on yours, right?
Yeah.
Okay, that's cool. Now you only need that one probe. Yeah. All right. Well, see, we found out something. We learned something tonight for you calling in. Look at that, man. It saved you ordering another probe.
Yeah. Now I just need to find something to look at. It would be, I'm thinking I should go to eBay and find some old radios or something to try and work on.
Well, you know,
Learn from.
You might want to just play and look at wave patterns and different things. Get you a little cheapy signal generator, little RF generator that, you know, has a dial on it. You can change the frequency and look at it there and learn how to dial it in on your scope. Get you an audio generator, or make you an audio oscillator. Take you something like a little NE555 and a few resistors and a pot, and you can actually make you an audio generator that covers a pretty good range, and that would be really a lot of fun to look at on your scope. And when you're not using it for an audio generator, plug you a key into it and make it a code practice oscillator.
Yeah, I do need one of those.
They used to have a chip called like the 8038 was a waveform generator that had triangle waves, square waves, sine waves.
Yeah.
And you could vary it over the entire audio range up to maybe about 100 kilohertz.
They actually have a
the XR 2211 and 2206 modulator and demodulator, something like that, right?
Mm-hmm.
Yep.
Right.
I just used one of those.
The 2211 was the demodulator.
Yeah, I used that in my.
I think it's the 2206 was the.
Yes, and they used to be very rare to find recently, but now I think they're clones, Chinese clones, because they're back again.
Yeah, I'm able to get them. I use that in my RIDI decoder in one of my projects, and there's I think it's the AD 8034, if I'm not mistaken, does the three waveforms, the triangle, square, and sine waves, and it does it up to 30 meg or higher, I think.
Very cool. Charlie, I did a prediction on the one balloon that's out there west of Chile. It'll be flying just south of Uruguay in 2 days from now.
Okay.
So you have 2 days to get things all hooked up, but that one will be on 20 meters.
That's on 20 meters. Okay.
20 meter whisper, yeah.
But Fernando, Ignacio is after those in 20 meters, right?
Yeah, his is on 20, and he's got 1 or 2 flying around right now. If you go to that site, I sent you the link in the chat, the amateur.soundhub.org, and you click on K4UAH-2, and then there's a link that says float in the window on the left. You click on the float button, it'll show you the predicted flight path for that particular balloon.
So -2 here.
Yeah, and you click on float, and it will show you that it goes right across Argentina, south of Uruguay.
Okay, I press float, and yes, there it goes. Oh, okay, the prediction, yes.
And you click on each of the dots, it'll tell you the date and time of each of the dots.
Like makes like a cone, right, for the prediction.
Yeah, every dot is every 6 hours, I think.
Okay. So it'll go, yes.
But that's the prediction for where it's going to fly next. And you can do that to any of the balloons that have that float button on it. Tom's balloon with Glenn is you had to turn that float button off, but if you go to W5 KUB-114, then you can do the same thing for that one and see where it's going next.
Well, we need to break out of South America. The southern hemisphere, and as you were saying earlier, Bill, we were getting very close to the South Pole, but man, we got to get up north a little bit. We need to start flying around a little higher up there. I'm trying to think where.
They keep trying.
Yeah, they keep trying, but they just don't seem to.
Well, but WK 115, it's okay.
Yeah.
Yeah, they're still pretty low.
114, I just did the prediction for 114, and 114 is also heading for Argentina. That's Glenn's call sign, KW5.
The only one which is a bit complicated is 115, maybe, which will go over Antarctica.
Right. So it's been a fascinating study so far.
Yeah, I'd like to see what Todd has to say about all of this as far as what he's getting in terms of data.
Well, we'll have him on the show here when he gets back and settle down. And
he has plotted it on a polar map, and so it makes a lot more sense to watch it from a polar view than this Mercator map projection.
Yeah. Well, there are not a whole lot of landmarks down there.
Yeah. Well, 114 will make a nice ride before getting, but then we'll get to a nice level there, mid way in Argentina.
Yeah.
So,
Right now, I don't know. Well, it's dark there right now. These 114 and 113.
Actually, it's not dark there right now
Well,
because this is the time of year where
I think 115 is in the dark.
no, there's no dark in this time of year.
Yeah, but you see where 115 is? Look at it on the
Well,
map.
he's a little further north. Yeah.
I mean, yeah.
115's in the dark.
these balloons are closer to the equator than you are.
Yeah.
Of course.
The 113, I thought it was going to cross the equator this week. It got down to about 2 degrees from it, and I thought it was going to cross, but it didn't. Now,
Well, it's heading back down again.
is it my friend AA6DY was flying one of our group's trackers here, and we've been watching it, and it crossed the equator. It's been flying in the northern. It crossed the equator, and it went across. I think it went across Chile, maybe went into Chile.
I just looked at the prediction map, Tom, for 113,
Yeah.
W5KUB-113, and it shows a possibility of it heading down towards eastern off the coast of Brazil. So this one may actually cross into the southern hemisphere and stay there for a while.
Well, the AA6DY didn't stay below very long, maybe just a couple of days,
Right.
and then it popped right back up, so I don't
But
know.
this one looks like it will pop up for a little bit, but its potential of heading on down to the South America. There was a German balloon. It's called NOB. What it is? It started off in Germany months ago, and it crossed. There it is, off the coast of Australia. NOB 14. It's Delta Bravo. I forget what the number is, but it's a German call sign, and he launched that months ago in the northern hemisphere, and it's been floating in the southern hemisphere for months now.
Mm-hmm.
So he's hanging out with us all now.
So we
See,
are aware of
yeah.
that.
Ignacio's flight, LU1ESY 34, is over in New Zealand right now.
Yeah.
Yeah, and Dash 36, it's over South Africa.
I see that, yeah. So
All
there
right.
are, I think there are more balloons in the southern hemisphere now than there are in the north. That's kind of a first.
Yeah. All right. Hey, we're going to go ahead and turn off and terminate the show tonight. Thanks to everybody out there watching. Glad we had you with us tonight. Be sure and come back next week and shoot us an email if you got any ideas or you want to be on the show or you got something you want to talk about. Shoot us an email, tom@w5kub.com. We'll see you guys next week. 73 to everybody.
73.
Let's see, how can I end this? I know what we'll do. We'll just end it with some fire and water. Yeah.
Control Alt Delete.
Fire and water. Let's see. If I can figure out how to do that. One is this. Oh, that's not it. It doesn't seem to be working.
Yeah.
Interesting. That doesn't seem to be working. Interesting. Does Handbot
Okay.
work? It's not even working. He doesn't want to work. But yeah, let's see if
people are going to think you're going to be giving out prizes.
Well, no,
Yeah.
he said, don't mess with me. He didn't say, let's give out a prize. He said, don't mess with me. Okay, I don't know why it's not running. I guess my program is starting to get hosed up here. Good night to everybody out there if you're still watching. So we'll see you next week. 73.